Hi guys, today we are going to learn how to identify outliers using the IQR or the interquartile range. So a lot of times we just look at a data set or a graph or a plot and we just say, well, that must be an outlier, right? An outlier is an extreme value, either a very low extreme or a very high extreme. For example, my 7th grade math class, they're all 7th graders. It would be an outlier if I had a 5-year-old in my 7th grade math class, right? Because all of my students are 12 and 13. That's a really low outlier. It would also be an outlier if I had a 20-year-old in my 7th grade math class. They would be an outlier. They're a very low or a very high extreme number. Today, we're going to learn how to mathematically identify what an outlier is using the interquartile range, okay? So, because we have to use the interquartile range, I just want to talk about what that is. Remember, that's the difference between the 3rd quartile and the 1st quartile. So it's like range, but it's just the difference between the 2 quartiles. So here's my lower quartile, 3. My upper quartile is 5. So the interquartile range would be 2, because 5 minus 3 equals 2. So my IQR here would be 2. We're going to talk about how we're going to use that to find an outlier. But I just want to go over a few things again. Remember, this first dot, that's your smallest value. It's your minimum value. The second dot at the very end is your maximum value. That's your greatest value. The first line represents your lower quartile, so the middle between the minimum and your median. The middle is median. Median means middle. And then this is my upper quartile, so that's the middle number between your median and the greatest number. Now, keep in mind that each section is a quarter of the data. So each section is worth 25%. Okay, so I'm just going to add that in here. So this is 25%, this is 25%, this is 25%, and this is 25%. So this box in the middle represents half of the data. So this box is the middle 50%. Okay, we want to look at that to identify outliers. So this middle 50% of the data, we're going to use that to determine if there's outliers. So remember, this is my box plot. This is my middle 50%. In this second box plot, it looks like there's a very low outlier here because most of the data is up here, but we're not sure. I can say that there's probably an outlier in this data set, but we're going to determine that mathematically. And your textbook says to do that, we have to find the interquartile range, and then it says a data value is an outlier if it's quartile 1 minus 1.5 times the IQR, or if it's greater than quartile 3 plus the 1.5 times the IQR. Now this sounds very confusing. We're going to do a few examples together and work through some problems to identify outliers. I broke it down into four easy steps. Step 1, you're going to calculate the interquartile range. So your upper quartile minus your lower quartile. Step 2, you're going to take that IQR and multiply it by 1.5. You will then add it to quartile 3 and subtract it from quartile 1. Anything bigger than this value here is going to be an outlier, and anything smaller than this value here will be a low outlier. Okay? Let's just do a few examples together. So looking at this, it's talking about pounds of honey collected per hive. It looks like this here is an outlier. See how this is really skewed? It looks like there's a very high outlier. We're going to calculate it to see if there is. So step 1, it says calculate the IQR. Okay, so we're going to do that. So it's the upper quartile minus the lower quartile. So upper quartile is 63 minus my lower quartile, which is 54. So 63 minus 54 is 9. So that's step 1. Step 1 is just to tell me what the IQR is, which is 9. Okay. Then it says to multiply your IQR times 1.5. So 9 times 1.5 is 13.5. Okay. So Step 3, you're going to take quartile 3. That's this here, right? This is quartile 3. And you're going to add 13.5 to that. So this is 1.5 times IQR. So you're going to add 13.5 to your upper quartile. All right, and we're just going to do that mathematically down here. So 63 plus 1.5 times the IQR is 13.5. So it's whatever you multiply the IQR by 1.5, that's going to give you this value here, and that's 76.5. Okay? So when I add to 13.65, I get 73.65, or 76.5. And that is right here. All right, so that means that when I add 13.5 to this, I call this my safe zone. This is safe. Anything in here is considered safe. Anything past this is going to be an outlier. So anything in this zone is safe. Well, what does that mean? That means I have to have an outlier over here somewhere. Now, we don't know how many values are in this data, so I don't know if 77 is an outlier, 78. There could be multiple numbers here. We don't know how many numbers there are. I do know that here is an outlier. There is an outlier, at least one outlier there. Okay, but I'm not done because I could have a low outlier over here. It doesn't appear to look like one, but it could be one. So I now have to take quartile 1, which is 54, and I'm going to subtract the 13.5 from that. Okay, so here, from here, I'm going to subtract 13.5. So I'm doing 1.5 of the boxes to the left and to the right of the middle 50%. So 54 minus 13.5 is, hold on, 40.5. Okay, so 40.5 is actually off of my number line. So that means like maybe all the way over here. This is all going to be considered my safe zone. So when I say safe, all of these numbers are safe. They are not an outlier. So this is my safe zone. If I have any numbers past this safe zone, it is an outlier. So there are no low outliers. There's only a high outlier. So I'm going to go down here and it says identify outliers. There is at least one high outlier, and that would be my maximum value at 80. So I know there's at least one outlier in this data set. Okay, let's try a few more so that you get the hang of it. Okay, step 1, calculate the inner quartile range. So I do that by taking my upper quartile and subtracting my lower quartile from it. So 50 minus 40 is my inner quartile range. That's 10. Then I have to take my IQR and multiply that by 1.5, and I immediately know that that's 15 because half of 15.5 is 5. 10 plus 5 is 15. Okay. So this is 1.5 of this middle 50%. Okay. And how we're going to do it is we're going to add 15 to the upper quartile. So here's my upper quartile. And I'm going to add 15 to that. And that's going to be my safe zone. So anything within those 15. Okay. So 50 plus 15 is 65. So 65 is my safe zone. From here to here is my safe zone. I'm going to write safe zone. And this is not mathematically, this is not a mathematical term. I just call it safe zone. It just has always helped me remember how to find an outlier. I showed you what the steps were via textbook. It just says to multiply it by 1.5, add it to the upper quartile, and anything past that. So that means any number past your safe zone is an outlier. So that means there is an outlier here. There's at least one outlier, okay? At least one, and that would be at about 74, but there can be more. We don't know how many numbers are here, okay? Now, there can also be a low outlier, so we're going to determine that, and we do that by doing quartile 1 minus 15. So quartile 1 is 40, and we're going to subtract 15, and that's 25. So from 25 to the lower quartile is my safe zone. So here we subtract 15 to go the opposite way, and this is called my safe zone. Anything past that is a low outlier. And again, we don't have any low outliers because 25 is exactly my minimum value. So we don't have any low outliers, but we have at least one high outlier at about 74. It looks like that's about 74. I'm not exactly positive, okay? All right, let's do another example. I just want to keep showing you these so that you get the hang of it. So step 1 again, we're going to calculate the interquartile range. So we take our upper quartile and subtract our lower quartile. So 23 minus 16 is 7. So that means the range of the middle 50% is 7. Okay, then we have to multiply that by 1.5. So 7 times 1.5 is 10.5. So that means 1.5 of these boxes is 10.5 long. Okay, from there, you have to add that to your upper quartile and subtract it from your lower quartile. Okay, so my upper quartile is 23. We're going to add 10.5, and that'll give us the safe zone, and that's 33.5. So here's my upper quartile. If I add 10.5, that's 33.5. That's like way off my number line, so I know I don't have any numbers greater than 33.5. Therefore, I don't have any high outliers, which is great. You don't want any outliers. So that's my safe zone. Perfect. No high outliers. Now let's check quartile 1. So quartile 1 is 16 minus the 10.5, and that's 5.5. Therefore, we don't have any low outliers either because 5.5 is off my number line again. So this is my safe zone. So I do not have any outliers. That's perfect. All right, let's try another. Well, this one looks like there's a really low outlier. It just looks like it, right? This is a lot longer and a lot longer than the middle 50%, but we're going to calculate it mathematically. Now this looks like it's a little bit past 4, so I'm just going to estimate, and that my upper quartile is 6. So to find my IQR, I have to do my upper quartile minus my lower quartile. We'll call that 4.8. Okay, so 6 minus 4.8 is 1.2. Then, so 1.2 is the range of the box. We now have to multiply that by 1.5, and that gives me 1.8. Okay, 1.8. So the 1.8 is 1.5 times this box, so it's 1.5 of it. And from here, we have to add that to our upper quartile and subtract it from our lower quartile. So when I add it to my upper quartile, 6 plus 1.8 is 7.8. And then my lower quartile is 4.8 minus 1.8, and that gives me 3. Let me make this a little bigger. All right, so that means that from my upper quartile of 6 all the way to 7.8, that is my safe zone. Oh, past a little bit. So here is anything safe. Anything past my safe zone is an outlier. Okay, so that means I don't have any high outliers. That's great. Now let's look at my lower quartile. So my lower quartile, I'm going to start at 4.8. My safe zone goes to 3. Anything less than that is going to be an outlier. So this here is my safe zone. All of these numbers are safe. Okay, notice these boxes are always going to be the same because it's adding 1.8 to the right and subtracting 1.8 to the left. So what does this mean? That means that I have at least one outlier here. I could have 2 outliers here. I could have 3 outliers here because we don't know what the data set is, but I know that there's at least one low outlier. And I know that one of the numbers is my minimum value. So my minimum value is 0, so I know that 0 is an outlier. At least one outlier at 0. And your English teacher would yell at me if I didn't capitalize the first letter. All right, we're going to do one more because this one's a little different. I'm not giving you a box plot. I'm giving you a set of numbers, okay? And I have to identify the interquartile range. That means that I need to put the numbers in order from least to greatest first because I have to find the interquartile range, and that means I need my lower and upper quartiles. Okay, so I have 12. 26, 25, 26, 27, 29, 31, 32. And I'm going to check to make sure that I have all my numbers. And I want to do this especially, one, I want to make sure that I have all my numbers, and 2, I want you to see how I check it because in your problems this week and last week, a lot of you forgot to check and then you were missing a number. 27, 29, 31, 32. I have all my numbers. Okay, so now from here I can find my median, my lower, my upper quartiles. Okay, so 3, 3, 27 is my middle number. That's my median. Okay, then I'm going to look at these numbers to find my median of this, which is my lower quartile, and that is 25. And then I look at the rest of my numbers, and it's going to be the median of the upper half of the data is going to be my upper quartile, and that's 31. So 25 is my lower quartile, and 31 is my upper quartile. So now to find the interquartile range, I put a W there, sorry. 31 minus 25, right? The range is the upper quartile minus the lower quartile, and that is 6. Okay. Now I have to take that number and multiply it by 1.5. So 6 times 1.5, half of 6 is 3. So 6 plus 3 is 9. So 6 times 1.5 is 9. Now I have to add that to my quartile 3. So Q3 is 31 plus 9. That's going to give me 40. So that means any number past 40 is going to be an outlier. I don't have any number bigger than 40. So that means there aren't any high outliers. Now I'm going to take my quartile 1, which is 25, and I'm going to subtract 9 from that. And that gives me 16. So any number smaller than 16 is going to be an outlier. Less than that, and that's 12. So I know that there is only one outlier because I have the numbers here. And I can see that there's only one number less than 16. So there's only one outlier at 12. Okay, and if it helps, you could have created a box plot to help you view this data like we did in the previous problems. Okay, you guys can go ahead and stop here and then go back to your Schoology page and you're going to complete today's assignment. You're going to practice this again tomorrow. So if you're struggling tomorrow or after today, go ahead back and rewatch this video to help you. If you have any questions, make sure you email me. All right, have a great day, guys.